Hi there, this is Ryan Malloy here at the Worldwide Center of Mathematics. In this video, we're going to discuss how to calculate the domain of a graph. Now, the domain of a graph is, simply put, the range of values for which the graph is defined. And we'll start with this function here, our blue squiggly curve, which looks like it could be the graph of a trigonometric function, perhaps a cosine curve, for example. Now, we'll see that we don't have any labels on our axis here. So you might think, oh, well, it's almost impossible to determine what values this is defined for. But you'll notice that we have these pointy arrows at the very end of our curve. What that typically means when you're graphing a function is that the behavior will continue out to infinity, or in this case, to negative infinity. So from this picture, we can safely assume that this graph is defined for all values. So we can write it negative infinity to infinity, or sometimes you'll see this notation, which is a shorthand for all real numbers. This is our domain. Okay, moving on to our second example. This one looks a little bit more complicated. This is called a piecewise graph. You notice that it's not one continuous curve, but it is in fact broken up into several different chunks. So let's start thinking about which values this graph is defined for. We see we can go from -3 to -2 all continuously, but then it jumps onto the next curve. But this is defined at -2. So we can see that every value from -3 all the way up to 1 is defined. But then at 1, it jumps again, from here to here. But again, we see this closed circle, which indicates that this graph is defined at the endpoint of this curve. So we can go from -3 all the way up to 1 and then onwards, and we'll still have all of its values defined. Then we have another discontinuity here. It looks like it's at around 2.5. We see there's a hole in this curve. But again, the graph is still defined, so we have another point above our original curve. So between -3 and 3, there's really only one point for which the graph is not defined, and that's this open endpoint here. So when we're writing the domain, use a closed bracket at first to indicate that it is defined at -3. And then we use a right parenthesis at the other side to indicate that it is not defined at 3, but it is for every value up to 3. Finally, we have this graph here, which is broken into two pieces, which are not connected. We have this chunk from -6 to -2. Note that these tick marks are multiples of 2 this time, not of 1. It's always important to check the scale of your graph. And then we have another chunk from 2 up until positive infinity, as we note with this arrow, but with a discontinuity at 4. So how can we indicate this domain? Well, we see -6 to -2, nothing too tricky there. And then to indicate that there are two separate subdomains, so to speak, we can use this symbol, which means the union. So we'll take the union of -6 to -2 inclusive with 2, and it goes up to 4, which is not defined. And we can take another union, 4 up to positive infinity. Alternatively, you could state that this includes 2 to positive infinity and then simply leave out 4. But this notation works just as well. My name is Ryan Malloy, and we've just discussed how to calculate the domain of a graph.